Right, so let's go back to our Clojure, introduction to Clojure. In the previous part, we installed Clojure on the GitHub code space on Ubuntu. Right, it is pretty simple. We basically follow the script using here's the installation command, basically curl, run it, sudo install, basically on. We have our Clojure installed. So now also we run a little hello world, right? It turns out the namespace is optional. We see so we use semicolon for comments, right? Again, if you Visual Studio Code, of course this will works, right? Control// works for commenting, uncommenting, just the usual things. But now there were some extra things which you could add. And one of those things is something called dependencies file, right? It's extra file. Specifies, again, if you're building something bigger, right? You can skip, again, you can see for small programs, you don't need this actually, right? But let's see if we can set it up, because maybe you have something much more, more complex. So we might want to check this file, right? So I have very simple, let's do a very simple one. Let's do a very simple one, right? And we need also, so I'll call it deps edn, I believe. Yeah, okay, nice. You see, the plugin realized this is the correct name. Now the question, what do we write here, right? So we want to say something this, of course, and if we want some pass, right? For now, pass, right? Source. What does this mean? What are we saying? Essentially that our code actually is not going to live in this folder. There's going to be a subfolder, pass, right? That might be enough, but I think the guide recommends also using Maven. Who knows what Maven is, right? Do you know, guys, what Maven is? Okay, again, you're lucky you're not using Java at your work. I know usually some people are working on Java projects. So Maven is basically, I would say, a super package manager, right? It's Java Maven, right? It's one of the biggest in the world, kind of like PyPy for Python, basically, right? Software project management comprehension tool, right? Maybe even has bigger ambitions, I think, than PyPy, right? Has basically, what this means is, when you use this, you basically import basically any library, right? It makes it very powerful. Has basically everything under the sun, right? So if you're building a serious project, you probably will be using Maven. It's under Apache projects, of course, one of the bigger projects, right? So we'll probably want to use it. And the question is, where does our Maven live? So dependencies, right? So this is the idea. Dependencies, right? And it's saying, okay, orgs Clojure, right? So this means actually, this is kind of, I would say, too ambitious, right? Because what's our version of Clojure, right? Version 112, right? So I would say those names are not correct. Let's go to Maven and Clojure. Let's double check, right? Let's double check Maven repository. Repository. Let's double check. Search. I think this is the correct. Yeah. So basically, let's check for Clojure. And 5/20 September 5, pretty recent. That's what we want. So idea is we will want to use this. So we don't want alpha, beta. We don't want any of that stuff. We want something stable. We're using 112. So I would say this is what you want to use, right? September 5th, right? That makes sense, right? Again, because AI is saying this, that does not look correct to me. I will go with 12.0, right? Again, and I will, for now, I'm not going to use Clojure script. Asynchronous programming, for now, we'll skip it, right? So we will leave that for another day, right? What I'll do is, I think this will work. Let's try this. Can we comment this out? Let's see. We'll see, right? Because this is not a Clojure file. It's a MDN file, right? So development, basically, build file, basically, right? So there's potential that this will, maybe I need to delete, right? Some configuration files don't allow comments. As you know, famously JSON, if using JSON for configuration, you don't have comments, right? So let's see now. So what I did is I said my files live at source. Aha. But I don't have a source map, right? So I need to, of course, make a source file, right? Source, right? And I will move my main here, right? move, right? So now the question is, if I run it, remember my history, right? Right, those who don't remember the history are, what's the saying? Are doomed to repeat it, right? So let's try to remember history, and I use this command, right? So will this work or not? It's supposed to work, right? So what I can do is, again, this is using my little Linux command line magic, right? And now it's 27 command. Let's see what happens. Will it work or not? It should in principle, but we'll see. Big test. All right. So something still did not work. Okay. It did not find main Clojure init class on class path. Okay. That's not a good sign, but let's see, did he do anything badly here? We didn't do anything too badly here. All right. If I right, so if I go again, so if I skip this, if I go to cd source, right, will this still work? I think it will still work, right? It should. I don't see why not. Yeah, this is the preset. So how about this? What happens if I do this? This will give me. Okay, right. All right. So M flag probably runs the main. I would imagine. I don't know. I have not checked the. Who needs manual anyways, right? We are cowboy coding, right? We're just running things and seeing if things break, right? Okay. But so we can use this. So I would still like to use this M flag, right? And maybe there's something not quite correct. Maybe I need to update something, right? Maybe let's read this one more time, see how we do it. How do you run it, right? Git dependencies, how to run commands, aliases, right? Central. Okay. Well, let's look at the command. Maybe we can fix this before we run. I would like to get everything properly. I mean, it's already proper, but again, maybe for your homework you don't need this, right? If you're building a larger project, you might want to. Let's try this. Let's take a look at this here, right? Of course, in old days, we could, of course, ChatGPT would work as well, right? Enable, right? So let's take a look. Stack Overflow, right? Docs are wrong. Okay. On a root where deep depths EDN exist. Yeah, okay, let's take a look. So this is basically the things which can start to make things a little bit more too complex than needed, right? It's basically a path dependencies and pathing problem, right? So where is our jar lives, right? I would say I say for today we'll skip it, right? I don't really want to, because we don't really need it, right? As far as learning actual language, right? But it would be good to actually fix this if you're running something bigger which imports external libraries, right? Maybe some big project, right? But okay. But otherwise, we use this Clojure main and it will work, basically, right? Okay. Now let's do some more coding. Let's do a Fizzbuzz, right? Let's do a Fizzbuzz. I think Fizzbuzz is a good one, right? Fizzbuzz should probably work. I think so. Might be a good sort of get you guys sort of started, and maybe also meanwhile I can also see what else I can show you. Maybe I have some from the notebooks. Right. Installation we done. Key features we done. Right. So Factorial, we can start with Factorial, right? I'm lazy, so I'll probably just copy this code. But no, so basically what is, again, this might be even better start with this than actually with Fizzbuzz, right? So it is going to calculate Factorial, and what it's going to use, of course, the favorite of functional programming is going to use recursion, right? So define Factorial, and basically you call it. And notice here, you call Factorial. Look at all these parentheses, right? So let's do a Factorial program. Let's do a Factorial. Right? So I'll go to sources. Let me update this, right? So, we don't need this here. There's So we're gonna ignore the cache, right? So Clojure project cache, we don't need that, right? We don't need the caching. CP cache, right? We don't want this. We want this to be under ignore, right? Git ignore. So Clojure projects, right? There's things you don't want to. So Clojure cache. So Clojure projects. What did I call it, right? I think this, right? Yep. Okay, very smart. AI is actually even help me do this, right? I am too lazy to do this. So I am now CP cache. Did I do it correctly? Yeah. So main. So let's see. No CP cache Clojure. Oh, projects. Yep. Okay. Matter. Now 4. Okay. Now we're good. So we renamed. We moved things around, and we're good. We added the caching. You don't want to commit cache to your Git repository, obviously, right? So moved source files for Clojure, right? Again, synchronize changes, and we should be good to go. Right. So now let's go back to this one. What happens if I go back here? So Clojure main CLG. What will happen? It probably won't fire. No, it doesn't fire. Okay, yeah, so you'll just go to source. Yeah, okay, we'll just go around from here. Okay, yeah. All right, so let's do a file. We are in a source. No, we are in a here, right? And we'll make a new file. We'll call it Factorial, for example, right? Let's see if we can run it. Let's see if the main file, we don't need the main name. Let's do this, Factorial. So again, I'll use namespace, right? Namespace, right? Good practice. Not really needed, but okay. NS main, or let's see if this is okay still, right? Oh, let's make a factorial function, right? Yeah, in fact, that's exactly, AI has seen this, probably this factorial so many times before. So what's still happening? It says match file name. All right, we can do factorial. All right, factorial, but then we have a problem, right? We have name conflict, right? Let's do this, right? And we need to call it like here, right? Or my factor or something like that, right? So again, this is not necessarily, but okay. But we of course now need to call it, right? Right? You use public variable, right? We need to call it, but of course we want to print it, right? And we want to call it. We want now by printing value for 5. Okay. So basically, print line factorial, right? And that should do it, right? Right? So again, this minus sign, don't worry about it. It's basically because it's sort of like the way Clojure often likes to use these function names like this. But again, we could skip this part, right? Namespace, right? So factorial namespace should be this match this, right? So namespace should match the file name, right? Yeah. The function name could be anything. Could be anything. Yeah. Hyphen is a convention, basically. Okay, let's see if this runs. Okay, so we have factorial code, right? Really easy, right? So, Clojure, M, and factorial, right? I use tab, completion, easy, right? So, let's see if this works now. On 120, it works, Eureka, right? Piece of cake, right? So what do we learn here? Look at code. Right, so there's incoming, right, n, right, it's coming in for factorial. So what is this part here, right, this if. So what happens here? Let's think about this here, this part here. It's an if, right? So how does if work in Clojure? Basically, it returns value, right? If so, this means it's comparison. This is Boolean, basically here. Compare n with 0. What we call this in recursion, it's a base case, right? It's a base case. On base case, we return 1. Just like in your regular factorial program, right? In Python, right? And of course, if it's not a base case, right, then you do this whole thing. So what's the potential problem here, by the way? Well, how about if I put negative 10, right? It'll keep going down, right? So maybe less than equal? I think I'll do less than equal. I'm a little bit afraid of that, right? And then we get 1, right? The question is, okay, can you define negative factorial, right? That's the question. It's not really defined. Yes?
No, you cannot.
No, it's not defined. So yeah, in this particular method, right? Basically, you probably, you could use less than equal, right? You could use this, right? This would be, then you don't have the error, potential error of runaway loop, right? Okay, now we are pretty good. How about the arguments, right? So this works, right? We saw in our main that there was argument option, right? Right? Let's do that. Let's do it. Let's make a function that reads arguments. Yeah, yeah. Provide a number. So, if empty arguments, let's see how many do we have. Let's see, 1, 2, 3, 4, 5, 6, 7. We're missing one parenthesis, right? Look at this. This is classical Lisp, right? No, one. No, we have closed one here. So wait. 1, 2, 3, 4, 5, 6, 7, 8. And yeah, we have 2 closed. So yeah, looks good. Okay, so what's happening? So basically, if we don't have an argument, we're going to use a Java parse int. It's from Java language, right? And then what do we do, right? We return a print factorial, right? So, and if you don't provide a number, basically, in command line as argument. Okay. Okay. Now we run this, right? And this should be main, right? We run it, and basically, we remember correctly. Main, not like that, not like that. It should be main, and I forget now how to run it without argument. I think you could just run it without. I believe you can do it like this. No, we earlier defined it, right? I think we have like no. Program. Yeah, let's see what happens. Well, now the good result. It's not gonna break, right? Let's see what happens. We bring a little factorial here, right? That'll work, right? And so also the question is this part here, right? And might be a problem because we're having 2 calls. Okay, all right. That's good. Good. All right. So that works, but we don't have the argument. Now the question is that worked. How about now? Let's read command line arguments. I think it was. 1 second. Now, oh yeah, I know you have to leave. So yeah, so let's read the command line arguments. So there was supposed to be a way to do it. Now, if I can remember correctly, let me comment this everything out, because right. No, I don't think it was. Print line first, command line args. Huh. Maybe there is a command for this. Let's double check now. And maybe I'll check, of course, check my lecture notes. Command lines, replit. We used. Okay, this is all done. If I remember correctly. How do we do arguments? I think there was a run Clojure with command line arguments. This is again main arguments and then running. Okay, this is all run. It exists here. It is in a core, right? Creates a list of our arguments. This looks like okay. And no, I did this everything correctly, but the question is here, this is all correct, right? However, the problem might be that I need to specify maybe potential. This is 6 years ago, right? Not, of course, again, this would be nice to have, right? Because I don't want to keep running, without command. Command line is just most applications depend on this, right? So how could we run it? Let's have it read the arguments, right? Args, right? Clojure core defined already, so maybe we can just. Oh wait, what happens if I run it like? Can I just run it? Let's see what happens now. Will nothing happen? No, nothing. How about this? I think now we'll have the error, right? Yeah. Right, but we would like to run. But this is AI is stupid, right? No, I don't. We can do that, of course. Let's read command line arguments and run them with main. No, that's not it. I can do that by my hand. So the args should come automatically, or do I need to pass a flag? I guess I have to ask ChatGPT for this, right? Let me see if I have my commands somewhere here. Main. It should run. So let's look at Clojure flags, right? Clojure command line flags, right? Let's take a look at those, right? CLI reference. Right, let's take a look. So invoke Clojure main using aliases. Okay, that's what we're doing, right? That's good. Clojure options. Maybe there's something. Run tool. Function to execute, right? Right? Function arguments, right? So we can do things like, okay. Okay. So this is what we're doing. We've been doing this, right? Running a script, which is fine. And we could, of course, do things like this, right? Which is kind of silly, but it's possible, right? Meaning we run them as a, it should work. Yeah, it works. 1 + 1 is 2, right? So you can just single eval, right? That's fine as well. The question is how to get this command. So this part here, how to pass command line arguments. How to pass command line arguments to Clojure. No. This is actually again Clojureverse. I know some students had an issue with this before as well, right? So main is fine. Okay. I guess we need to fix something here. Okay, you could ignore the warning. How about, let's try this one more time. So this was a problem here. Factorial, init, Clojure init, or factorial something. Okay, but all right. But I guess we won't go through that today. For the command line arguments, we still have another lecture on that. Something for next week, for Thursday. Again, not crucial, but would be nice to have, right? But let's look at more syntax again. So again, you saw how if works. Again, let's do Fizzbuzz, right? Let's do a Fizzbuzz, right? So maybe let's do like, let's see what happens if we do 10, right? That's pretty big factorial, right? Yeah, it works. So if I do 100, will it work? All right, let's do that. It's probably going to break because this is Java language. Yeah, a long overflow, right? Because not an, factorial of 100 is too big, right? And so we'll stick with 10. All right, we'll stick with 10 and it works back again. Yeah, okay. Right. So of course data types again parse integer, right? You probably want to have a long integer, right? Parse long, right? So cast also. Underneath the Clojure has a very strong data type system. Okay, let's go to our Fizzbuzz. Right, we have our factorial, we'll do our Fizzbuzz. CLG, right? Again, namespace Fizzbuzz, right? Right. And let's do our Fizzbuzz. Let's do a simple Fizzbuzz. We will use Fizz5 and Buzz7, right? And basically, and of course we know that, right? So what do we need? So how do we make a program in Clojure? It requires you to define functions, right? So let's see. This actually I think is a little bit too much. This is again maybe already. So we have not using it, right? Fizzbuzz is not called, right? So let's take a look, right? So it's going to be parameter, right? So what's happening here? If again as a classical, we check. Notice what the syntax is like. Again, first of all, we're going to run it, right? Let's run it. Let's run it, right? We need to run it, of course, right? Right, main 100. So it actually goes up to n, right? Right, and do range, do sequence, right? So do sequence is basically a way of applying or basically do each, right? I think it's in JavaScript it's called do each, right? We run it for each value, right? Do sequence, right? And we print the value for that particular number. So a way of writing a loop. Now is everything okay or is something still not quite right? It looks okay. All right. So classical Fizzbuzz. And let's run it. Looks pretty good to me, but let's see if we can explore it. And it works indeed. Let's double check it. 70 Fizzbuzz, 35 should be Fizzbuzz. All right. Yeah, works perfectly. Okay. So how does it work? So let's look at this function, right? So we define what we do for each step, right? So we have AND, right, which checks is this equal to 0, right? Again, we have a function mod n7, right, for the n. So n has a local scope, right? Has local scope, right? Obviously here as you want. And again, and something, right? Mod. So notice how we keep closing on parentheses, right? Again, some people really like this approach. Again, I'm not knocking it, right? But again, in late 1950s when this came out, right? On comparison, the only alternative was to use Fortran or COBOL, right? This was probably a breath of fresh air, right? So again, but you do have to write a lot of this parenthesized style, right? So again, and then of course you close everything, right? Formatting is not crucial, but of course nice to see what's happening. So that's our first case, right? Then, if that's true, if it's not true, you check the other cases, right? And this is the base, meaning the case when nothing is, when n is just a normal number, which does not divide with anything, right? And again, please provide an argument as argument, right? And here it works, but I would see if this actually we could fix this, right? So let's do it for like 40, right? It will work. So, and it works up to 40. Okay. So basic constructions, what have we learned so far? If, right, loops, again, we do have, Clojure is not dogmatic. It lets you use these loop constructions, right? But again, of course, often it depends on these recursive. Could we do this recursively completely? We could, right? But do sequence, of course, is the regular way of doing it, right? So again, n range 1, right, on this inc. So what is inc, right? Right? Range on this is basically range 1 to this part here, right? So inc, I believe, was increased or was it included, right? I think it's included, I believe, correctly, right? So print line, right? Now let's go back to our code, right? Where's my... Any questions so far, or is it pretty clear? Pretty easy, right? Yeah. So again, but it forces you to basically compose everything in functions, right? So let me see, we have something we have not touched on. We saw the lists are core part. The vectors will look on Thursday, right? The maps and sets. So namespaces, right? REPL driven, concurrency, right? Define function, right? Oh yeah, but let's do our mapping and squaring, right? So again, our even squares or from our last lecture where I showed the Python approach. So even squares, so map, reduce, map, filter, and apply. Right? Let's do that. All right, let's try this. On Factorial on, let's do map, filter, reduce. Right? Filter, map, reduce. Let's do that. Filter, map, reduce. CLG. Right. Let's demonstrate a simple filter, map, reduce example by filtering even numbers from a list, squaring them, and then summing them. Very simple example. Let's do namespace first, right? Of course, we have to do that, right? Let's do that. So, filter, map, reduce, list, right? Well, this is, of course, actually shows how simple it is to use it, right? Well, let's call it, right, main, right, on, right, and we pass arguments, right? And now we will do this here. Run it, right? Main. Okay, so very simple, right? But of course we could make something, use it here, something, give a list of something else. Again, list processing language, right? Now everything looks okay to me. What's missing? And this is, why is this complaining? You have to leave. We're going to finish in a couple minutes, but yeah, you can leave. Okay, that's fine. All right. Let's check, is there any obvious error here? So notice how concise this example is, right? Reduce, plus, right? Map, right? So what's going on here, right? So this is very interesting stuff here. These are basically placeholders, basically, right? So mapping, right? each. So basically each value is multiplied by itself, right? So of course I would like to maybe make this a squaring function, maybe, right? This example will work, right? So what we'll do is you'll get 2 squared, 4 squared, 6 squared, right? 8 squared and 10 squared. All right, let's take a look. Clojure and filter. Come on, filter. Okay, but where did you go wrong? End of line. Oh, I missed. Okay, so 1, 2, 3, 4, 4, right? 4. So where's the problem here? Did we miss a parenthesis here somewhere? In the file. There is something happening here. Or maybe, let's see, we closed one time. So we opened up 1, 2, 3, 4. So 4, close 3, 4, 1. Looks okay to me. How did I mess up here? Let's take a look. Looks very, very correct actually, but maybe let's do this separately, right? Let's define square. Let's define a function that maps numbers to their squares, right? Yeah, that might be it, right? So that would be probably this part here, right? Let's define now. Let's define a function that gets even numbers from their list, right? Even. So basically, this is sort of wrapper. So okay, of course, here it is just basically, so really just a wrapper. Yeah. And then finally, right? Now, how about summing the numbers in a function? Right? Again, that might be easier to understand, right? So again, square brackets, local scope. Square brackets, local scope, right? Square brackets here mean local scope, right? Just like I said. There goes my back. Okay, now we call it again. So filter back. Now we can yeah, right? Sum map square field. Okay, so this looks better now, right? Sum. First we filter, right? Filter even numbers, right? Filter map, right? Because look what's happening here, right? So filter requires what arguments? A function. So filter requires 2 arguments. Yeah. Now map also requires, right? So finally sum requires just a list. So we're going backwards. We're working backwards. Yeah. Okay. Argument. The list. Right. So it's all about the list. Okay. And that should do it. So basically what's happening, this will be returned, right? The last value will be returned here. Okay. Now will this work? Maybe this, again, it's something missing here. Something's missing. What's missing? Oh, this parenthesis maybe. 1, 2, 3, 4 again. No. What's missing? Is there an error here? You see it? There's something missing here. Okay, yes, there's one bracket missing. Oh, maybe let's add one. Okay, like I told you, this is all about the brackets, right? Or parentheses. Yeah, I think that's it. Yeah. Like, you know the joke about when Soviet Union captured American codes from 1960s, and they knew this list because the last page was all parentheses, basically, right? Yeah, it's a joke, at least programmer's joke, basically. But yeah, that's the case. You end up, eventually longer program will have literally like 50 parentheses closing, basically, all right? That's when you run everything. So let's run it, and if it works, please work. Yeah, 220. Is that correct? Yeah. Of course, we could have added some wrapper to in the mapping here, right? Print line, maybe, right? We have sort of again, right? A side quest, right? We could have also not only sum, but also print line, basically, right? In our sum, right? Having a way to print it, right? Would be nice, right? Print line. Can you do this? Let's print the list of numbers here as a side effect. I think this will work, right? Oops, I think this will work. Let's try a look, right? Yeah. Why not? I think it will work. Yeah, it worked. Yeah. All right. So, looks correct. 220. Yeah. All right. So, this is like the core way of working in a functional language. This filter, map, reduce, depending what you want to do, right? So your looping is sort of built in, right? You're either mapping something, right? Converting something, maybe filtering, meaning there's going to be probably same number of items or less, or of course reducing to single numeric value, right? Okay, I think that's it for today. So next, on Thursday, we will look at the data structures, at the vector operations, at key maps, right? Associative arrays.